1552 Magnetic force between two balls. This Java code calculates the maximum-minimum distance between M balls placed in sorted positions. The algorithm uses a binary search approach to find the optimal distance. The helper method canPlaceBalls checks if it's possible to place M balls with at least a given minimum distance, force between them. Explanation 1. We first sort the position array in ascending order to simplify the calculation of magnetic force. 2. We use binary search to find the maximum-minimum magnetic force. The search range is from 1 to the maximum possible distance between any two baskets. 3. In each iteration of the binary search, we calculate the midpoint mid between left and right. We call the canPlaceBalls function to check if it's possible to place M balls in the baskets with a minimum magnetic force of mid. If it's possible, we update the result to mid and continue searching in the right half of the range to try finding a larger minimum magnetic force. If it's not possible, we search in the left half of the range. 4. The canPlaceBalls function checks if it's possible to place M balls in the baskets with a minimum magnetic force of distance. We initialize count to 1, representing the first ball placed in the first basket. We iterate through the position array starting from index 1. If the difference between the current position and the last position where a ball was placed is greater than or equal to distance, we place a ball at the current position and increment count. After the iteration, we check if count is greater than or equal to M. If it is, it means we can place M balls with the given minimum magnetic force. 5. Finally, we return the result, which represents the maximum-minimum magnetic force between any two balls. The time complexity of this solution is O n log n, where n is the length of the position array. The binary search takes O log n iterations, and in each iteration we perform a linear scan of the position array, which takes O n time. The space complexity is O1, as we only use a constant amount of extra space.